topic is all about integers in computers. In computer science, Wikipedia, an integer is a datum of integral data type, a data type that represents some range of mathematical integers. Integral data types may be of different sizes and may not be allowed to contain negative values. Datum is something used as a basis for calculating or measuring the distance between datum points. The value of an item with an integral type is the mathematical integer that is corresponds to. Integral types may be unsigned or capable of representing only non-negative integers, or signed capable of representing negative integers as well. Integers are commonly represented in a computer as a group of binary digits or bits. The size of the grouping varies, so the set of integer sizes available varies between different types of computers. Computer hardware, including virtual machines, nearly always provide a way to represent a processor register or memory address as an integer. An integer value is typically specified in the source code of a program as a sequence of digits optionally prefixed with positive or negative. In mathematics, positive numbers, including the zero, are represented as unsigned numbers. That is, we do not put the positive sign in front of them to show that they are positive numbers. However, when dealing with negative numbers, we do use a positive sign in front of the number to show that the number is negative in value and different from a positive unsigned value, and the same is true with signed binary numbers. Some programming languages allow other notations, such as hexadecimal base 16 or octal base 8. Some programming languages also permit digit group separators. The representation of this datum is the way the value is stored in the computer's memory. Unlike mathematical integers, a typical datum in a computer has some minimal and maximum possible value. Since digital systems operate with binary numbers that are represented in terms of zeros and ones, called a bit or binary digit, it is fall into several sizes of numbers, which such as a byte. An 8-bit binary numbers or a byte can have a value ranging from this example. The most common representation of a positive integer is a string of bits using the binary numeral system. The order of memory bytes storing the bits varies. The width of precision of an integral type is the number of bits in its representation. An integral type with n bits can encode 2 to the power of n numbers. For example, an unsigned type typically represents the non-negative values 0 through 2 to the power of n minus 1. Other encodings of integer values to bit patterns are sometimes used. Example, positive 0 and negative 0 would like the positive 0 is 0, 0, 0, and negative 0 is 1, 0, 0, 0, respectively as a signed 4-bit binary number. So we can see that using this method, there can be two representations for 0. A positive 0 is 0, 0, 0, 2, and also a negative 0 is equals to 1, 0, 0, 0, 2, which can be complication for computers and digital system. Another example is binary coded decimal or gray code, or as printed character code such as ASCII, or American Standard Code for Information Interchange. The example for this representation, the value 1 in binary would normally be 001 and 2 would be 010. In gray code, these values are represented as 001 and 011. That way, incrementing a value from 1 to 2 requires only one bit to change instead of two. Incrementing meaning the amount or degree by which something changes, especially the amount of positive or negative change in the value of one or more set of variables.
Octal number system. The octal number system, or shortly OCT, uses the number 8 as its base. Octal numerical can be made for binary number by grouping consecutive binary digits into group of 3, starting from the right. Decimal number system. The decimal number system has 10 in its base, which in decimal is written 10, as is the base is every positional numerical system.
Decimal to hexadecimal is a conversion process involving the two-number system. The original number is in the decimal format, base of 10, and is converted to hexadecimal format, base 16. So, how to convert decimal numbers to hexadecimal numbers? So first, we need to understand the decimal numbers is based on 10 system. For example, digit 49. The first digit is 0 to 9. For example, 0, 1, 2, 3, 4, 5, 6, 7, 8. So, the decimal system is based on the 10 number system. So, how about the hexadecimal numbers? It composed of two words, hexa and decimal. Hexa corresponds to 6 and decimal corresponds to 10. So if we add 6 plus 10, it becomes 16. So the hexadecimal system is the number system is base 16. Now, we need to know that corresponds from the decimal system to hexadecimal system. The decimal system corresponds to the hexadecimal system, has the same value of the hexadecimal system. 1 refers to 1, 2 corresponds to 2, 3 6 corresponds to 6, 7 corresponds to 7, 8 corresponds to 8, and 9 corresponds to 9. 10 corresponds to 4. Does not correspond to 10. 10 is the decimal system. 10 corresponds to A. 11 corresponds to B. 13 corresponds to 13. I corresponds to D. 14 corresponds to E. And 15 corresponds to F. We stop in 16 because we include 0 going to 15, that is the 16 numbers. Hexadecimal system based on 16 numbers and letters. Now, we will going to talk about how to convert decimal numbers to hexadecimal numbers using calculator. You can easily do it kung meron kang calculator. Let's start 479. Divide. Divided by 16 equals to 29.375 equals. So 29, let's we have find the reminders. Multiple 16 by 0.9375. It will the remainder of 15. 29 divided by 16 equals to 1.8125 equals 1 remainder. So multiply by the 16 by 0.8125. The remainder is 13. So focuses on the number 1, 13, and 15. So the 1, 13, 15. So the remaining convert them to hexadecimal numbers. 1 corresponds to 1, 13 corresponds to D, 15 corresponds to F. So 1 is the most significant digit and F is less so. We need to divide it. So 4, 7, 4 based on 16 significant system is 1 D F subscript of 16 integers to indicate that these hexadecimal numbers are hexadecimal numbers. So let's try another example. 894 divided by 16 equals to 55.875 and substitute the integers of 55. Multiply the reminders of 16 times 14 times 55.875 equals 14. 55 divided by 16 equals 3.4375. So multiply the 16 times 0.4375 equals 7. 3 divided by 16 equals 0.1875. And multiply the 16 to 6.1875 equals 3. The remainders of 3. 3 refers to 3. 7 refers to 7. 14 responds to E. So 894 is the hexadecimal subsystem. Numbers is 37E and 16 hexadecimal numbers.
Operation in binary numbers is an operation that requires two inputs. These inputs are known as operand. The binary operation of addition, multiplication, subtraction, and division takes place on two operands. Even when we add any three binary numbers, we first add two numbers and then the third number will be added to the result of the two numbers. What is operand? Something such as a quantity or data that is operated on a mathematical operation. Also, the address in a computer instruction of data to be operated on, like 0 and 1. Binary operation or dyadic operation is a calculation that combines two elements to produce another element. More formally, a binary operation is an operation of arity 2. For example, suppose that the number 101 is the base of 2 or the binary. So here we got the 101 and its value of 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. In here, we're going to convert the binary to decimal. So first, 2 to the power of 2 times 1, we have 2 to the power of 2. The 0 and 2 to the power of 5 cannot be multiplied. And the next one is 2 to the power of 0 times 1 equals 1. So, mag-1 na siya kay wala naman ting ano diri pag times mo 1 na lang gina siya diri. And then equals 2 to the power of 2 equals 4 because 2 times 2 equals 4 and then plus 1 equals 5. So our decimal is 5. So next, addition of binary numbers. To add the binary numbers, let us remember the rules or the magic table. So 0 plus 0 equals 0, 0 plus 1 equals 1, and 1 plus 0 equals 1, and then 1 plus 1 equals 1, 0. So carry 1, and then 1 plus 1 plus 1 equals 1, 1, and then carry 1. So example, we have 1001101 plus 011100. So 1 plus 0 equals 1, and then 0 plus 0 equals 0, and then 1 plus 1 equals 1, 0. So carry 1, bring down 0, and then 1 plus 1 plus 1 equals 1, 1, carry 1 equals bring down 1, and then 1 plus 0 plus 1, so 1, 0, then 1 plus 0 equals 1, and then bring down 1. Then kung sa decimal, same gap kung paano siya kuwaon. So 64 plus 8 plus 4 plus 1 equals 77, and then in here, 16 plus 8 plus 4 equals 28, and equals, so 78 plus 28 equals 105, equals 105. So, subtraction of binary. To subtract the binary number, let us remember the rules or the magic table. So, 0 minus 0 equals 0, 1 minus 0 equals 1, 1 minus 1 equals 0, and 0 minus 1 cannot be, so we have to borrow 1. Example, 1011011 minus 1101101. So 1 minus 1 equals 0, 1 minus 0 equals 1, and 0 minus 1 cannot be. So magborrow kita sang 1 dire. So ang 1 may mo siya 0, and dire 1, 0. So equals 1, and then 0 minus 0 equals 0. And then 1 minus 1 equals 0, and 0 minus 1 cannot be. So same pa rin, magbaborrow tayo dito, and then 1, 0 minus 1 equals 1. Same pa rin kung paano tayo kumuha ng decimal. 64 plus 16 plus 8 plus 2 plus 1 equals 91. But here, kailangan natin siya subtract. So, 91 minus 53 equals 38. Next, we have the multiplication of binary. To multiply the binary number, let us remember the rules or the magic table. So, 0 times 0 equals 0, 0 times 1 equals 0, 1 times 0 equals 0, and 1 times 1 equals 1. For example. So, here we have 1001101 times 10. So, 0 times 1 equals 0. So, expected na kay kung i-times mo siya sa 0 equals 0. So, 0 na tanan dire. And then, 1 times 1 equals 1. 1 times 0 equals 0. 1 times 1 equals 1, 1 times 1 equals 1, and 1 times 0 equals 0, 1 times 0 equals 0, and 1 times 1 equals 1. So, dire, ang imuuna ton, ibuhatan natin ang rules ng addition. So, bring down na lang yan tanan, kay total same. So, sa decimal, same lang yapon, 77 equals 77 equals 2 plus equals 79. And here, you have equals 151, so 79 over 151. So next, we have the division of binary. To divide the binary number, let us remember the rules or the magic table. So if kaya ma-divide, ang answer is 1. If dili siya ma-divide, the answer is 0. So for example, so we have 1001 divide 10100. So sa 3 bits muna tayo magfo-focus dito sa tatlong ito. So we're going to read the binary numbers as decimal. So sa divisor, meron tayong 100 and then sa dividend, meron tayong 101. So kapag malaki ang value ng dividend kaysa sa divisor, kaya natin siyang i-divide. So ang answer natin is 1. If maliit naman is 0. So kasi malaki ang ating dividend, so 1 dito, then multiply it to 100, we have 100, and then subtract, we have 100, bring down 0, so maliit ang dividend, magiging 0 siya dito, so 0 multiply to 100, we have 0, 0, 0, subtract, we have 0, 1, 0, then bring down 0, and then equal na siya sa ating divisor. So we're going to put 1 and then multiply it to 100 again. And then we have 100, subtract, and then the final equal is 0, 0, 0. So ang answer natin is 101.